the equation of the tangent to the circle x square plus y square equals to 3, which is inclined at 60 degrees with the x axis, the circle. Center of the given circle is origin. Now, the tangent to the circle inclined an angle 60 degrees with the x axis, 60 degrees with x axis. Required equation of the tangent. If suppose circle equation x square plus y square equals to r square, x square plus y square equals to r square. Now, slope of the tangent equals to m, slope of the tangent equals to m, then equation of the tangent to the circle is y equals to mx plus r into square root of 1 plus m square. Now, we get two tangents, but one is plus, other is minus. Y equals mx plus or minus r into square root of 1 plus m square. Y equals mx plus or minus r into square root of 1 plus m square. Here, radius of the circle r equals to root 3, r equals to root 3, r square equals to 3, r equals to root 3. But tangent inclined an angle 60 degrees with x axis, then slope of the tangent m equals to tan 60, that equals to root 3. Slope of the tangent equals to root 3, tan 60 degrees root 3. Then required equations of the tangents, y equals to mx, m nothing but root 3 into x plus or minus r equals to root 3 into square root of 1 plus m square, 1 plus 3, or y equals to root 3x plus or minus 2 root 3 are the required tangents. Y equals to root 3x plus or minus 2 root 3. First option is correct. Only one tangent given, that is plus 2 root 3. The radius of any circle touching the lines 3x minus 4y plus 5 equals to 0, 6x minus 8y minus 9 equals to 0 is. Now, observe given equations, the two lines are parallel to each other. The given two lines parallel to each other, Now, a circle touching two parallel lines, then the distance between parallel lines, equals to diameter of the circle. The distance between two parallel lines equals to diameter of the circle. Now, radius of the circle equals to diameter by 2, d by 2. The distance between two parallel lines by 2 equals to radius of the circle. But first equation multiplied it by 2, we get 6x minus 8y plus 10 equals to 0. Now, distance between two parallel lines equals to c2 minus c1 by square root of a square plus b square under modulus. Distance between two parallel lines equals to mod of c2 minus c1 by square root of a square plus b square. Now, d equals to c2 minus c1, 10 minus of minus plus 9 by square root of 6 square plus 8 square, or that equals to 19 by 10. Diameter of the circle equals to 19 by 10, then radius of the circle equals to d by 2, that equals to 19 by 20. The radius of the circle equals to 19 by 20, fourth option. Radius of the circle equals to 19 by 20, fourth option. The equation of the tangents to the circle x square plus y square equals to 16, x square plus y square equals to 16, which are inclined at an angle 60 degrees to the x axis, 60 degrees to the x axis, the circle. Center of the circle origin. But the tangents inclined an angle 60 degrees. We get two tangents. They are parallel to each other. Required equations of these two tangents, equations of two tangents. Radius of the circle r equals to 4 and slope of the tangent m equals to tan 60 or that equals to root 3. Tan 60 equals to root 3. Now, equations of the tangents y equals to mx plus or minus r into square root of 1 plus m square. Y equals to mx plus or minus r into square root of 1 plus m square. Now, y equals to here m nothing but root 3 into x plus or minus radius of the circle 4 into square root of 1 plus root 3 whole square 3, or y equals to root 3x plus or minus 8 are the required tangents. Y equals to root 3x plus or minus 8. First option is the correct. First option. The area of the triangle formed by the coordinate axis and the tangent at x1 y1, tangent at x1 y1 on the circle x square plus y square equals to a square. X square plus y square equals to a square. The given circle, center of the circle is origin and radius of the circle a, x axis, y axis. If suppose the given point, consider p x1 y1. P x1 y1 is a point on the circle, a point on the circle. If suppose a tangent is drawn to the circle at the point P, a tangent is drawn to the circle at the point P, it meets x axis at A, y axis at B, consider. Now, required area of the triangle OAB, area of the triangle OAB required, area of the triangle OAB. Now, equation of the tangent to the circle at x1 y1 is s1 equals to 0. Equation of the tangent to the circle x square plus y square equals to a square at x1 y1 is s1 equals to 0. That is nothing but xx1 plus y1 equals to a square. Equation of the tangent or equation of AB equals to xx1 plus y1 equals to a square. Now, it converted into intercept form, we get x by a square by x1 plus y by a square by y1 equals to 1. Now, x intercept to OA equals to a square by x1, y intercept to OB equals to a square by y1, a square by y1. Now, area of the triangle OAB, area of the triangle OAB equals to half into mod of OA into OB. Area of the triangle OAB equals to half into x intercept into y intercept, or that equals to half into OA equals to a square by x1 into OB equals to a square by y1, or that equals to a to the power of 4 by 2 into mod of x1 y1 square units. The area of the triangle OAB equals to a to the power of 4 by 2 into mod of x1 y1. Now, second option is the correct. Second option. The locus of point of intersection of two perpendicular tangents to the circle x square plus y square equals to a square. The locus of point of intersection of perpendicular tangents to the circle. If suppose a circle, if p x1 y1 lies outside of the circle, p x1 y1 lies outside of the circle, from external point two tangents can be drawn to the circle. Two tangents can be drawn to the circle. From external point two tangents can be drawn to the circle. Consider A and B are points of contact of these tangents. A and B are points of contact of these tangents, and the center of the circle consider C. Let C be the center of the circle. Now, join AC, PC, AC, PC. But PA or PB is length of the tangent, both are equal. PA equals to same as PB. Then also BC. Always radius perpendicular to tangent. Now, AC perpendicular to PA. Similarly, BC perpendicular to PB. Now, in triangles PAC and triangle PBC. PA equals to same as PB, AC equals to BC. That is nothing but radius of the circle. PC is common side for both the triangles, and angle A equals to angle B. Angle A equals to angle B. Then the two triangles are congruent. Then in triangle PAC and triangle PBC, angle APC equals to same as angle CPB. These two angles are equal. If semi-angle between the pair of tangents consider theta, semi-angle equals to theta by 2. Semi-angle equals to theta by 2. Now in triangle PAC, tan theta by 2 equals to, in triangle PAC, tan theta by 2 equals to AC by opposite side by adjacent side PA. Tan theta by 2 equals to AC by PA. AC nothing but radius of the circle. AC nothing but radius of the circle, and PA is length of the tangent, root S11. Now theta by 2 equals to tan inverse R by root S11. Tan inverse R by root S11. If angle between the pair of tangents is theta, then theta by 2 equals to 2 tan inverse R by root S11. Otherwise theta equals to 2 tan inverse R by root S11. If angle between the pair of tangents is theta, then theta equals to 2 tan inverse R by root S11. If angle between the pair of tangents, theta equals to 90 degrees. Theta equals to 90 degrees. Theta by 2, 45 degrees. That equals to tan inverse R by root S11. Now tan 45 1, then we get R equals to root S11. If angle between the pair of tangents is 90 degrees, the condition is radius of the circle and length of the tangent both are equal. If angle between the pair of tangents is 90 degrees, then radius of the circle and length of the tangent both are equal. R equals to root S11 is the condition. Now required the locus of point of intersection of perpendicular tangents. If consider x1 y1 with the point of intersection of perpendicular tangents, the circle S equals to 0, or here S nothing but x square plus y square minus a square equals to 0. Now perpendicular tangents means the angle between the pair of tangents 90 degrees, but angle between the pair of tangents 90 degrees, then condition R equals to root S11. R equals to root S11. Now radius of the given circle is A equals to root S11, x1 square plus y1 square minus a square. Now squaring on both sides and further simplifying, we get x square plus y square equals to 2a square. Now locus of point of intersection of perpendicular tangents is x square plus y square equals to 2a square. Now it is also a circle concentric with the given circle, because center of the circle x square plus y square equals to 2a square and x square plus y square equals to a square, both are same. Then this circle is called directed circle of the given circle. Means the locus of point of intersection of the perpendicular tangents, the locus of point of intersection of perpendicular tangents to a circle is also a circle which is concentric with the given circle, then this circle is called directed circle of the given circle. The circle is called directed circle of the given circle. Now option is x square plus y square equals to 2a square, third option. If x square plus y square minus 4x plus 6y plus k equals to 0 touches x axis, then k equals to, touches x axis, then k equals to, the given circle touches x axis, required the value of k, Now the circle x square plus y square plus 2gx plus 2fy plus c equals to 0, or the general circle touches x axis, then the condition is g square equals to c. G square equals to c. Here the value of g nothing but half of the coefficient of x. G square equals to 4 equals to c nothing but k. Now k equals to 4. Answer is 4. K equals to 4. Fourth option. The center of the circle touching y axis at 0, 3 and making an intercept 2 units on the positive x axis. The circle touches y axis at 0, 3 and making an intercept of length 2 units on the positive x axis. Required the center of the circle. Now first the equation of y axis is x equals to 0. Consider the point circle means center 0, 3 and radius 0. Now equation of point circle 0, 3 is x minus 0 whole square plus y minus 3 whole square equals to 0. The point circle x square plus y minus 3 whole square equals to 0, or further simplifying we get x square plus y square minus 6y plus 9 equals to 0. The equation of the point circle 0, 3 is x square plus y square minus 6y plus 9 equals to 0. Now the required circle passing through points of intersection of point circle and y axis or x equals to 0, then its equation must be in the form of s plus lambda L equals to 0. Here s equals x square plus y square minus 6y plus 9 equals to 0. S plus lambda L. Now x square plus y square minus 6y plus 9 plus lambda x equals to 0. Now given the length of intercept made by the circle on the x axis equals to 2 units. The length of intercept made by the circle on the x axis, formula 2 into square root of g square minus c, or that equals to 2 units given. 2 get cancel. Now g square minus c equals to 1, for implies here the value of g nothing but half of the coefficient of x. Now g square equals to lambda square by 4 minus c minus 9 equals to 0. Now lambda square equals to 36, for implies lambda equals to plus or minus 6. Now the required circle equation x square plus y square, here lambda nothing but plus or minus 6x minus 6y plus 9 equals to 0. Now two circles we get, one in the first quadrant, other in second quadrant. Now center equals to minus g minus f, center equals to plus or minus 3, 3. G square minus c equals to 1, lambda square by 4 minus 9 equals to 1. Now lambda square by 4 equals to 10, for implies lambda equals to root 40 or plus or minus 2 root 10. Now the circle's equations x square plus y square plus or minus 2 root 10 x minus 6y plus 9 equals to 0. Now required center equals to plus or minus root 10 comma 3, but center lie in the first quadrant, both x and y coordinates are positive, then root 10 comma 3, center of the required circle root 10 comma 3, third option. The equation of the circle which touches the lines x equals to 0, y equals to 0 and x equals to c and x equals to c. The equation of the circle x equals to 0, y equals to 0 and x equals to c touching these three lines. X equals to 0, nothing but y axis, y equals to 0, x axis, x equals to c, it is a straight line parallel to y axis, parallel to y axis. Now, required circle equation which touch the three lines. One we get in the first quadrant, another circle also we get, it is in the fourth quadrant. Required equation of one of the circle. Now, the distance between the straight lines x equals to 0 and x equals to c is c units. Now, it is nothing but the diameter of the circle. Diameter equals to c, then radius equals to c by 2. Now, center of the circle in the first quadrant c by 2 comma c by 2 and radius also c by 2. Next, another circle in the fourth quadrant, its center is c by 2 comma minus c by 2, radius c by 2. One circle center c by 2 comma c by 2, radius c by 2. For second circle center c by 2 comma minus c by 2 and radius c by 2. Now, equation of the first circle is x minus c by 2 whole square plus y minus c by 2 whole square equals to c by 2 whole square. Now, further simplify, we get x square plus y square minus cx minus cy, c square by 4, 1 c square by 4 cancel plus c square by 4 equals to 0. Now, one circle equation x square plus y square minus cx minus cy plus c square by 4 equals to 0. Similarly, in fourth quadrant circle, here we get plus cy plus or minus cy. But given only one circle equation, that is nothing but x square plus y square minus cx minus cy plus c square by 4. Fourth option is the correct. O is the origin. OA, OB are pair of tangents to the circle x square plus y square plus 2gx plus 2fi plus c equals to 0, that c greater than 0. Then the equation of circumcircle of the triangle OAB, the circle O is the origin. Now, c greater than 0, then origin lies outside of the circle. From external point, two tangents can be drawn. Now, OA and OB are tangents to the circle. OAB is a triangle. Required equation of circumcircle of the triangle OAB. Now, let C be the center of the circle. Now, join AC BC, also OC. In triangle OAC, angle A equals to 90 degrees. In triangle OAC, angle A equals to 90 degrees. Because always tangent and radius perpendicular to each other. Similarly, in triangle OBC, angle B equals to 90. Same reason, because OB tangent, BC radius. Now, in triangle OAC and in triangle OBC, OA equals to OB. That is nothing but length of the tangent. Next, AC equals to BC. Nothing but radius of the circle. And OC OC common side for both the triangles. OC common side for both the triangles. Then triangle OAC and triangle OBC both are congruent. Triangle OAC and triangle OBC both are congruent. And both are right angle triangles because angle A 90, angle B 90 degrees. Then OC is hypotenuse, common hypotenuse for both the triangles, common hypotenuse. If suppose a circle is drawn, the hypotenuse of a right angle triangle has a diameter, it compulsory passes through their right angled vertices. Means the circle OC has a diameter, passes through the points A and B, but the circle OC has a diameter passes through 3 vertices of the triangle OAB, then it is circumcircle of the triangle OAB, Now center of the given circle is minus G comma minus F. Just to write equation of the circle, given point and center of the given circle or extremities of diameter, we get equation of the circumcircle of the triangle OAB. Now required equation x minus 0 into x plus g plus y minus 0 into y plus f equals to 0. Further simplification, we get x square plus y square plus gx plus fy equals to 0. Now it is the equation of circumcircle of the triangle OAB. Now second option is the correct. The line y equals to x plus a root 2, touches the circle x square plus y square equals to a square, at P. Then the coordinates of the point P, then require the coordinates of the point P. The circle, given circle x square plus y square equals to a square. Center of the circle, origin 0, 0. The given line x minus y plus a root 2 equals to 0 touches the circle at the point P. Now require the coordinates of the point P. Now P nothing but the foot of the perpendicular of center on the tangent. If suppose the straight line equation, any general equation ax plus by plus c equals to 0, linear equation in terms of x and y. The tangent equation ax plus by plus c equals to 0. Point is 0, 0. Then foot of the perpendicular of origin on this line is minus ac by a square plus b square, minus bc by a square plus b square, or that equals to minus a equals to coefficient of x 1 into c equals to a root 2 by a square plus b square 1 plus 1, minus bc minus b equals to minus 1, c equals to a root 2 by a square plus b square 1 plus 1, or that equals to minus a root 2 by 2, minus of minus plus a root 2 by 2, or that equals to minus a by root 2, a by root 2. The required point of contact P, coordinates of the point P, minus a by root 2, a by root 2. Now fourth option, minus a by root 2, a by root 2. The length of the tangent from a point on the circle x square plus y square plus 2gx plus 2fy plus c equals to 0 to the circle x square plus y square plus 2gx plus 2fy plus c dash equals to 0. Require the length of the tangent from a point on the first circle to second circle, second circle. Now center of the first circle minus g comma minus f, center of the second circle also minus g comma minus f. Then the two circles are concentric circles. The center of the first circle minus g comma minus f, center of the second circle also minus g comma minus f. Then the two circles are concentric circles. Now from any point on the circle, if suppose x1 y1 p x1 y1 is a point on the first circle, it is first circle, consider s equals to 0, second s dash equals to 0. First circle s equals to 0, second circle s dash equals to 0. Now from anywhere on the point on the first circle, the lengths of the tangents are fixed because the two circles are concentric circles. The two circles are concentric circles. Now consider p x1 y1 be any point anywhere on the first circle. Now length of the tangent from x1 y1 to the second circle equals to root of s dash 1 1, or that equals to square root of x1 square plus y1 square plus 2g x1 plus 2f(y1) plus c dash. The length of the tangent from x1 y1 to the second circle is root s dash 1 1, that equals to square root of x1 square plus y1 square plus 2g x1 plus 2f(y1) plus c dash equals to 0. But the point x1 y1, the point p x1 y1 lies on the first circle, s equals to 0. Then the point x1 y1, substituting in the equation of the first circle, it must be satisfied. Means x1 square plus y1 square plus 2g x1 plus 2f(y1) plus c equals to 0, but the value of x1 square plus y1 square plus 2g x1 plus 2f(y1) equals to minus c. Now c taken right side. Now x1 square plus y1 square plus 2g x1 plus 2f(y1) equals to minus c. Now that equals to square root of minus c plus c dash, or that equals to root of c dash minus c. Now length of the tangent from any point on the first circle to second circle equals to square root of c dash minus c. Third option is the correct. If the length of the tangent from 2, 3 to the circle x square plus y square plus 6x plus 2ky minus 6 equals to 0, is equals to 7, require the value of k, then k equals to. Now the length of the tangent from 2, 3 to the circle is 7, required k value. Length of the tangent equals to root s11, that equals to square root of the point 2, 3, substitute in the equation of the circle, we get 4 plus 9 plus 12 plus 6k minus 6, what that equals to 7, Now 4 plus 9, 13 plus 12, 25, 25 minus 6, 19, root of 19 plus 6k equals to 7, squaring on both sides, 19 plus 6k equals to 49, 6k equals to 30, then k equals to 5. The value of k equals to 5, then third option is correct, k equals to 5. The length of intercept made by this circle x square plus y square minus 12x plus 14y plus 11 equals to 0 on the x-axis, required length of intercept made by this circle on the x-axis. The length of intercept made by this circle on x-axis equals to 2 into square root of g square minus c, or that equals to 2 into square root of g square 36 minus c minus 11, or that equals to 2 into square root of 25, that equals to 2 into 5, 10. Now 10, length of intercept made by the circle on the x-axis equals to 10, then second option is correct, second option. The length of intercept made by the circle x square plus y square plus 10x minus 12y minus 13 equals to 0. Minus 13 equals to 0 on the y-axis. On the y-axis. Similar problem, the length of intercept made by the circle on the y-axis equals to 2 into square root of f square minus c. 2 into square root of f square minus c, or that equals to 2 into square root of, here f equals to minus 6 whole square 36 minus of minus plus 13, or that equals to 2 into square root of 49, or 2 into 7 equals to 14. Now, fourth option is correct. Fourth option, the length of intercept made by the given circle on the y-axis equals to 14 units. The length of the chord x equals to 3y plus 13, x equals to 3y plus 13 on the circle x square plus y square, of the circle x square plus y square minus 4x plus 4y plus 3 equals to 0. The length of the chord x equals to 3y plus 13 of the circle x square plus y square minus 4x plus 4y plus 3 equals to 0. If suppose a circle and straight line intersect at 2 points A and B. Now, AB is called length of the chord. The distance between A and B is called length of the chord. Now, equation of the chord given x minus 3y minus 13 equals to 0. X minus 3y minus 13 equals to 0. Now, center of the circle, center of the given circle 2 comma minus 2, 2 comma minus 2, center of the given circle 2 comma minus 2, and radius of the circle equals to square root of g square plus f square minus c, 4 plus 4 minus 3, or that equals to root 5. Radius of the circle r equals to root 5, r equals to root 5. Required length of the chord AB. Now, if suppose the perpendicular distance from center of the circle to the chord, consider d units. The perpendicular distance, or consider d CD perpendicular to the chord AB, CD perpendicular to the chord AB, and D also midpoint of AB. Now, in triangle ACD, AD square equals to AC square hypotenuse square minus side square, CD square. Now, that equals to, here AC nothing but radius of the circle. Now, AC square equals to R square minus CD nothing but perpendicular distance from center to the chord is D. Now, CD square equals to D square. Now, AD equals to square root of R square minus D square. But required length of the chord AB, AB equals to 2AD, or that equals to 2 into square root of R square minus D square. The length of the chord AB equals to 2 into square root of R square minus D square, where R is radius of the circle, D is the perpendicular distance from center to the chord, Now, D equals to perpendicular distance from center minus 2 comma minus 2 to the line x minus 3y minus 13 equals to 0 is mod of 2 minus of minus plus 6 minus 13 by square root of 1 plus 9, or that equals to 5 by root 10, 5 by root 10. D equals to 5 by root 10, R equals to root 5. Then, length of the chord AB equals to 2 into square root of R square equals to 5 minus D square, 5 by root 10, D square equals to 25 by 10, or that equals to 2 into square root of 5 minus 5 by 2, or that equals to 2 into square root of, by taking LCM as 2, 10 minus 5, 5 by 2. 2 taken inside, that equals to root 10. Then length of the chord equals to root 10. Fourth option. If a circle passes through the points of intersection of the axis with the lines ax minus 5 plus 1 equals to 0 and x minus 2y plus 3 equals to 0. x minus 2y plus 3 equals to 0, then a equals to, if suppose the two lines, consider a1x plus b1y plus c1 equals to 0, second line a2x plus b2y plus c2 equals to 0. Now these lines intersect the coordinate axis in 4 concyclic points, require the condition. If suppose the circle x axis, y axis, one straight line intersect the coordinate axis in 2 points, that line equation consider a1x plus b1y plus c1 equals to 0. Second line also intersect the axis in 2 points. Second line equation a2x plus b2y plus c2 equals to 0. a2x plus b2y plus c2 equals to 0. But these 4 points lie on a circle. The 4 points lie on a circle. Required the condition. Now, first the combined equation of given two lines, that is consider S equals to. Combined equation nothing but multiplying two equations together we get a1x plus b1y plus c1 into a2x plus b2y plus c2 equals to 0. Now it is nothing but combined equation of given two lines. Now equation of x axis y equals to 0, y axis equation x equals to 0. Now combined equation of coordinate axis, xy equals to 0, that consider s dash equals to 0. Now the required circle passing through the points of intersection of the given lines with the coordinate axis, now are points of intersection of s equals to 0 and s dash equals to 0. The required circle passing through the points of intersection of s equals to 0 and s dash equals to 0, then its equation must be in the form of s plus lambda s dash equals to 0, or a1x plus b1y plus c1 into a2x plus b2y plus c2 plus lambda xy equals to 0. Now further simplifying, we get a1 a2 x square plus a1 b2 plus a2 b1 into xy plus b1 b2 y square plus a1 c2 plus a2 c1 into x plus b1 c2 plus b2 c1 into y plus c1 c2 equals to 0. Now it is second degree general equation. In terms of x and y. The second degree general equation in terms of x and y represents a circle, then coefficient of x square must be equals to coefficient of y square. Coefficient of x square equals to coefficient of y square. Now a1 a2 equals to b1 b2. a1 a2 equals to b1 b2. Now coefficient of x square equals to coefficient of y square. If suppose the lines a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 intersect the coordinate axis in concyclic points, then a1 a2 equals to b1 b2. Now a1 a2 a equals to b1 b2 minus 1 into minus 2 2. Now the value of a equals to 2. First option. The equation of the card of contact of the point 4, 2 with respect to the circle x square plus y square minus 5x plus 4y minus 3 equals to 0. The equation of card of contact of the point 4, 2 with respect to the circle x square plus y square minus 5x plus 4y minus 3 equals to 0. If suppose a circle P is a point, it lies outside of the circle or external point to the circle, From external point two tangents can be drawn. If suppose PA one tangent, PB second tangent drawn from the point P to the circle. Now AB, the chord AB is called chord of contact. Chord of contact of the point P with respect to the circle, of the point P with respect to the circle. If suppose the point P x1 y1, circle equation S equals to 0, circle equation S equals to 0, then equation of chord of contact is S1 equals to 0, S1 equals to 0. Now S1 x1, here x1 nothing but point 4 x1 y1 is 4 2, 4 2, x1 4x plus 2y minus 5 by 2 into x plus 4 plus 2 into y plus 2 minus 3 equals to 0. Now 4x plus 2y minus 5x by 2 minus 10 plus 2y plus 4 minus 3 equals to 0. Now 2 taking LCM, we get 8x minus 5x, 3x plus 2y plus 2y, 4y into 2, 8y, 4 minus 3, 1 minus 9 into 2 minus 18 equals to 0. Now the required equation of chord of contact is 3x plus 8y minus 18 equals to 0. Third option.